All right, so for section 4.2, we're going to talk about events and their probabilities. So first of all, we're going to classify an event as something that's going to occur. Okay, the sample points of those events are going to make up your sample space. Okay, so an event is a collection of sample points. Okay, so let's go to flipping a coin. My event is flipping a coin. Flipping coin. Okay. My sample points would be heads or tails. Okay. My sample space is going to be heads and tails because that's what can happen. Okay. So that what we're going to do is we're just kind of sort of fine-tuning our language and the vernacular that we're going to use for the rest of the semester. So what we have is, if events are equally likely, we call it a classical approach. Okay, so a classical approach, things are equally likely, so let's look at flipping a coin. The probability of each sample point in the event, okay, is just going to be the average. So in other words, I've got two things that I add together. Okay, so that means that each one has a 50-50 chance of happening. It's the average. Okay, it's 1 out of 2. Okay, so that's just going to be equally likely is your classical approach, and the probability is the average of everything happening. So let's go to let's talk about the suits in a card deck. So you have hearts, you have diamonds, you have clubs, and you have spades. Okay, so I can leave it that generic and not go into the parts of the suit. So in that case, my sample points are hearts, diamonds, clubs, spades. I can say that there is a 1 in 4, okay, a 1 out of 4 probability of me grabbing one of those because there's 1 out of 4 different possibilities. Okay, so that's going to be your average. Now, that's your classical approach. I can also go through and I can look at more of a weighted average. So if I'm looking at a weighted average, it means that there's more stuff that's going to be implied. There's more issues going on in the background. So let's just look at a deck of cards and let's narrow this down and start looking at how we're going to formalize this. So for instance, I want to list the sample points in a deck of cards in the event that a face card, meaning a card that has a face on it, okay, a face card is selected. So my list of sample points, I'm going to say my list of sample points is going to equal, okay, so what cards have faces on them? The cards that have faces are jacks, queens, and kings. And then I've got suits of hearts, diamonds, clubs, and spades. So what I can do is I can have a jack of hearts, a jack of diamonds, a jack of clubs, and a jack of spades. Okay? Well, what else can I have? I can have a queen of hearts, a queen of diamonds, a queen of clubs, and a queen of spades. What else can I have? I can have a king of hearts, king of diamonds, king of clubs, and king of spades. So the little curly brackets let me know that that's what I'm including as my sample points. Now I'm talking about something specific, so it really doesn't matter that there are other cards in the deck. Okay, I'm narrowing it down just because I'm asking you specific stuff. So what we can do is what's the probability of grabbing a face card randomly out of a deck of cards? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've got 12 out of 52. Well, 12 out of 52 actually reduces by 4 to 3 out of 13. So that's your probability right there. Okay, so how many's in my sample? What sample points am I talking about? There are 12 of them But how many cards are there in reality? There's 52. So if I'm just talking about the probability of grabbing a face card, what that's going to be is going to be just, it reduces to 3 out of 13. So theoretically, okay, what you have is for every 13 cards that you grab, one at a time, 3 of them will be face cards. That's what you're looking at. Now, what you also have is a weighted probability, okay, or a relative frequency. Okay, so for a relative frequency, it's still going to add up to 100, okay? In this case, 100, so all of the cards would be 52 out of 52, right? We're talking about just a certain portion, okay? A relative frequency, let's compare, okay? So if I've got 12 out of 52 face cards, okay, then which ones are not face cards? So 40 out of the 52, okay, 40 out of the 52 must not be face cards. So what we can do is change these probabilities. Instead of saying, well, 12 out of 52, which is 3 out of 13, and start doing from there, is we can look at a relative frequency. So what we're going to do is we're going to compare what happens. So what I have is 4 out of 52, not 4, what did I just say? 12 out of 52 is actually 0.2307%, or that's your decimal approximation. So 2307, on and on and on, which is roughly 23%. Okay, so your relative frequency would be your face cards are about 23%, which means your not face cards are going to be the complement of that, because it's all together got to add up to 100. So 100 minus 23 is going to be 77%. So about 77% of those are going to be not face cards. So what does that mean? About 23% of the time, if you grab one card, you're going to be grabbing a face card. About 77% of the time, if you grab a random card, it's not going to be a face card. So that's what you're looking at. Now, all you have to do to look at relative frequencies is you're just going to change these things into decimals. Okay, we like decimals better in statistics. Normally in math courses, we like fractions because they're more exact. But it's easier for our brains to comprehend the decimals. So you're going to notice us kind of sort of going away rapidly from using fractions, and we're going to be going to decimal representation. Okay, so that is 4.2. It's pretty basic and pretty straightforward. So that is 4.2.